Phenol. Acidity of phenol, alcohol, and water. Alcohol, water, and phenol have different acidity, means different Ka values. Why do we say that alcohol, water, and phenol are acid? Because they can form H plus ion. Alcohol, water, phenol can form H plus ion. That's why we say they are acidic. The acidity increases in the order of aliphatic. Alcohol is less acidic than water, water less acidic than phenol. Means phenol is the most acidic if we compare between these three. These three, alcohol, water, and phenol, they are weak acid. Water can form hydroxide ion, OH minus and H plus. So the Ka value 10 to the power of negative 14. And this one, alcohol can form alkoxide ion and H plus, the Ka value 10 to the power of negative 16. The phenol can form phenoxide ion and H plus, Ka value is about 10 to the power of negative 10. So the lower the Ka value, the more acidic it is. Okay, lower Ka value, more acidic it is. Means here phenol is the most acidic if we compare between these three because it has the lowest Ka value. Phenol is more acidic than aliphatic alcohol and water because phenoxide ion, so this is phenoxide ion, is stable than alkoxide than hydroxide. So this phenoxide ion is more stable than alkoxide and hydroxide in water. Okay, it's more stable. Why phenoxide ion is more stable? This is because the phenoxide ion form is stabilized by resonance effect. Because phenoxide ion has benzene ring. Alkoxide and hydroxide does not have benzene ring. Phenoxide, which has benzene ring, has the ability to spread the negative charge over carbon atoms rather than concentrated it on just one atom, produces more stable ion. So here phenoxide ion, O negative, it can spread the negative charge to here to become double bond and negatively charged over here. It can be spread over the benzene ring here, spread over the carbon atom in the benzene ring. So this resonance structure make it more stable ion, makes the phenoxide ion more stable. Okay, phenoxide ion more stable means it is easy to release the H plus. Because this is more stable, so it does not prefer to have the H over here, means it is easy to release H plus. So that's why phenol is most acidic, because it is most easiest to release the H plus. Why most easiest to release? Because it is most stable in this form. So for other than those three, the cyclic alcohol is less stable than the benzene ring. Here we have benzene ring and then alcohol on the straight chain, and then this one is more acidic. The straight chain has less carbon. Straight chain alcohol has less carbon, it's more acidic. And the phenol is the most acidic, means it is easiest to release the H plus. Chemical properties of phenol. Phenol can react with sodium and sodium hydroxide only. So if phenol reacts with sodium, it will form O minus and A plus. So it will remove its H plus and O minus and A plus ionic bond. Plus hydrogen gas will be released, but half because only one H atom, so half H2. For cyclohexanol reacts with Na, it will form O minus and A plus as well, plus half hydrogen gas release. If the phenol reacts with sodium hydroxide, means it is soluble in sodium hydroxide, but alcohol with 6 carbon atom or more do not. So this phenol is soluble in sodium hydroxide. It will release the H plus and it will be O minus and A plus H2O. For this one, the normal alcohol, not phenol, the alcohol straight chain with 6 carbon reacts with NaOH, almost insoluble, so it cannot form O minus and A plus for NaOH. For normal alcohol, the alcohol without the benzene ring, okay, other than phenol, alcohol other than phenol, it can react with Na metal, sodium metal, to produce O minus and A plus, but not with sodium hydroxide over here, not with sodium hydroxide. Only phenol can react with sodium hydroxide. However, ethanol does not react, because previously we said that 6 carbon atom or more do not. If less, it can react with sodium hydroxide, but more than 6, it cannot react with sodium hydroxide. But ethanol only has 2 carbon in the alcohol, but it does not react with sodium hydroxide because ethoxide ion is a stronger base than hydroxide ion. Okay, ethoxide stronger base than hydroxide ion, so reforming of alcohol will occur. Means here the ethanol reacts with sodium hydroxide, no reaction. This is because here ethoxide ion more reactive than hydroxide ion. For example here, when this ethanol form ethoxide and H plus, it form CH3 and CH2O minus and H plus, it will react back with the H plus. Okay, it will react back with the H plus. So no reaction can occur. This O minus will not react with Na plus. It will react back with the H plus, because this CH3 CH2O minus is more reactive than OH minus. So OH minus will not react with H plus. This CH3 CH2O minus will react back with H plus. So we cannot form CH3 CH2O minus and A plus. We cannot do that because it will react with H plus back, because it is more reactive than OH minus. So that's why there is no reaction with sodium hydroxide with ethanol. Chemical test for phenol using FeCl3 solution. So phenol reacts with FeCl3, purple complex will form. This FeCl3 will be in the middle of the benzene ring of the phenol, so purple complex will be formed if you react with FeCl3. If you react the phenol in bromine in water, tribromophenol will be formed here, white precipitate. The bromine will attach at carbon number 2, carbon number 4 and carbon number 6. 3 bromines in total will be attached in the phenol plus HBr as the side product. So white precipitate is formed. White precipitate is the tribromophenol over here. If you want to test whether there is presence of phenol or not, we can use FeCl3 or we can use bromine in water. If you use FeCl3, if there is phenol in there, purple complex will be formed. If you use bromine in water, if there is phenol in the solution, you can see white precipitate. The side product is HBr. Thank you.